So now we'll be talking about length of arc and chord of a cycle. So how do we measure the length of an arc and the chord of a cycle? So let's start with the length of an arc. So an arc is a portion of the circumference of a circle. So if I have a circle as shown here and I just take a section out of the circumference, that small section that I've taken is called the arc. So how do we calculate the length of an arc? Formula for calculating the length of an arc is given as 2 pi r times theta over 360. You might be familiar with this, seeing it in this format, 360 theta over 360 times 2 pi r, where r is the radius, theta is pi is 3.142, and theta is the angle subtended at the center of the circle. So let's see how we apply this to solve a question. So here we're told that a sector with an angle 60 degree has an arc length of 5 meters. So sector is a section of a circle, so we have a sector and this is the arc over here, and we're told that the angle is what, 60 degree, and we're told that the length of the arc is what, 5 meters. We're now asked to calculate the radius of the circle. So now we know that the formula for calculating the length of an arc length is given as what, theta over 360 times 2 pi r. But now we are given the arc length and we are told to find the radius. So we have to make the radius the subject of formula. So our arc length is 5 and our theta is what, 60 over 360 times 2 pi r. Now if I cross multiply, 60 times 2 gives me 120 times, and pi is what, 3.142, then times my radius is equals to my 5 times 360. Now if I divide both sides by 120 times 3.142 and I do the same here, times 3.142, this cancels this. So I'm left with my radius being equals to what, 4.774 meters. So the radius of this sector is what, 4.774 meters. So now let's look at another, let's move on to chords now. So what is a chord? A chord is a line that is drawn that touches the circumference at any 2 points. So as you can see, this line is drawn within the circle and it touches the circle or the circumference at this point and this point. So such a line drawn is called the chord. So how do we calculate the length of a chord? So the way we go about it is by using the concept as described. So let's imagine that this is the center of the circle now, and we'll call that O. So we know that a line drawn from the center to any part of the circle is called what? The radius. So this is the radius and this also is the radius. So what can we do now? Normally we'll be given the angle that the arc subtends on the center, and that angle. So now also we'll now be told to find length of the arc, and most of the time we'll be given the radius. So all we have to do basically is to make use of our SOHCAHTOA. And if you are not familiar with that, you should check out the section on trigonometry ratio. But this next example will illustrate this point better. So here we are told that a chord subtends an angle of 120 degree at the center of the circle. So basically you have a circle, okay, coming. So you have a circle, yes. So this is the center, and you have a chord. I am told that the chord subtends an angle of 120 degree at the center. So if we trace a line towards the center, and this line will represent the radius, and the angle subtended over here is what, is 120 degrees. Then we are told that if the radius of the circle is 7 centimeters, so we are told that the radius is 7 centimeters and here also is 7 centimeters, that we should find the length of the chord. So we should find this distance over here. So now I can bring out this triangle outside, and what do I have? I have something that looks like this. So I have this and this. And over here I have the angle to be 120 degrees, and I have it to be 7 and 7, and I'm trying to look at this length. Now if I draw a line perpendicular or straight down to this chord over here or this line over here, I have a right angle, and the angle here will be distributed equally. So this angle in this section will be 60 degrees, and this angle in this section will be 60 degrees. Now if I take out one of those section, I will have about 60 degrees over here. Now I have a right angle triangle, and here is 7. Now for my SOHCAHTOA, I know that sin theta is equals to opposite over hypotenuse. So my opposite is what I'm looking for, which is over here, because this is my opposite to the angle, equals to my hypotenuse times sin theta. So my hypotenuse in this case is 7, and my theta in this case is 16. And when I calculate that, that will be 7 times sin 60 is root 3 over 2, 2 here 1, 2 here 3.5, which gives me 3.5 root 3. So that means the length here is 3.5 root 3. So the length here is 3.5 root 3. And similarly, if I repeat this calculation for this side, since this triangle is similar to this triangle and they are equivalent triangle, this length also will be 3.5 root 3. And when I sum the lengths of both of them together, what do I have? It gives me 7 root 3. So 7 root 3 centimeter. So the length of this chord over here, which is the length from here to here, is 7 root 3 centimeter. So that is how you go about calculating the chord in a cycle. So that pretty much sums up our discussion on calculating the length of an arc and calculating the length of a chord.